And how was your day? Okay, yeah. This afternoon, we'll be looking at Laplace transform. And as you can see, it is introduced here, then followed by the definition. Here, Laplace transform gives an alternative approach for solving linear differential equations with boundary values without finding the general solution, the values of the arbitrary constant. And the definition, the Laplace transform of the function f of t is defined for all positive values of t. Then f of s is equals to integral exponential integral running from 0 to infinity exponential minus st f of t dt, provided the integral exists, is called the Laplace transform of f of t, and it is denoted as Laplace. F of t is equals to f of s equals to integral 0 to infinity exponential minus st f of t dt. So, should in case you are asked to define Laplace transform, this is what you are going to do.
So the first one or the second one?
This is the definition. Look at it. This is where it starts. This one is just introduction, brief introduction to Laplace transform. What Laplace transform is used. Is that clear? So, okay. So that is that. I can clean this, right?
Yes, sir.
You have done, right? So let's consider the linearity property of the Laplace transform. The linearity property of Laplace transform. The linearity property properties of the Laplace transform. Laplace transform. Okay. Yeah. Is nothing but something we have been doing as long as mathematics is concerned. Is that as long as mathematics is concerned, we know that if now we have Laplace of k f of t, this is equals to integral 0 to infinity exponential minus st k f of t dt. It means I want to find the linearity of this. It means we can rewrite this in this form. This is the same thing as, mind you, your k is what? Constant, 2 of us. So we can factor k, I'll bring it out from the integral to write integral 0 to infinity exponential minus st f of t dt. Amen?
Amen.
Then likewise, if we have, this is 1, 2. If we have Laplace of a f of t plus b f of t, this is the same thing as integral 0 to what? Infinity. Amen?
Amen.
Okay? So exponential minus st, amen.
Amen.
Open brackets, f of t, amen.
Amen.
Plus b f of t dt. Two of us. Then, yeah. Then this is the same thing as, if you can see what I am saying. This is the same as integral 0 to infinity exponential minus st a f of t dt, then plus integral 0 to what? Infinity. Amen?
Amen.
Yeah. We want to look at the linearity of this. It means we can, this is a constant, two of us. This is also what? A constant. We can factor it out. It means a integral 0 to what? Infinity exponential minus st f of what? T dt, then plus b integral 0 to what? Infinity exponential minus st f of t dt. Amen?
Amen.
Do you agree with me?
At this stage, I agree with this. The first stage we started.
Yes, sir?
The very first stage we started after this very two.
What? Yeah, this.
Up again.
This.
The second, the next. No, the second one. I mean, yeah, yes, sir. It's not the question you said.
Huh?
It's not the very.
No, we are just trying to define the linearity of this Laplace transform.
But I was thinking
Just like.
direct as the first one.
Huh?
I was thinking it would go direct just as the first one.
The first one is just constant now, but this one we have a plus b now, two of us. So we have to use this function to multiply this. Just like if we have a open bracket c plus d dt. Use this one to multiply, you have ac dt plus this one to multiply, you have what? A d dt. True of us. Not be so. Not so. Amen. Amen. So it's simple as ABC. Very simple as ABC. Can you see now? This is what I was trying to.
Orientation is locked. Rotate, advance, back. So you see what I'm saying? See orientation device lock. Rotate device lock.
You know how to create it. No, you want to face me. It's okay.
Sir, is it precise?
Yeah?
Is it like
I was trying to avoid this. It's okay. Okay. So So let's make progress, right?
Yes, sir.
Let us make progress. It's okay. So with the help of all this, I think, amen. Yeah. Is it not too far? It's okay. So with the help of this, at least we can be able to solve some problems. Is that clear? So let's go ahead to look at some problems, but before we solve problems, we'll look at the importance of Laplace transform. We'll consider, at least we have known the linearity of Laplace transform, two of us too. So, over down, this one.
Yeah.
Yeah.
I'm not done yet.
Okay.
This one is magic duster.
Huh?
This very one, it's my own. It's magic duster. I have to work very clean.
Miracle duster. Okay. Now, so far so good. So far so good. Importance of Laplace transform. The importance of Laplace transform. Amen?
Amen.
Okay. Yeah, before we look at the importance of Laplace transform, we'll quickly go back to our ND calculus, elementary calculus. Because if you don't have the knowledge of calculus, I don't think what we want to do is be able to comprehend with it. So let us go back to our elementary calculus. That is talking about indefinite integrals, right? You know, in our ordinary elementary calculus, indefinite integrals are of this form, a running from a to b dx. So when you come across functions of this form, these are what? Definite integrals, right?
Yes, sir.
Because you integrate to obtain value. Amen?
Amen.
You integrate to obtain the value. So now we want to integrate this function. But before we do that, let me just take you back to integration. Is that clear?
Yes, sir.
Because some of you have forgotten on how to integrate a given function. So let's go back to integration. Assuming you are asked to integrate integral ax raised to power n dx. You know, integration is the opposite of differentiation. So if we are to want to define integration mathematically, is that clear? We know that this is constant, this is x, then this is what? Raised to power n, true or false? So if you, whenever you are asked to integrate any function, this is the formula. It means this is equals to, this power, you are going to add 1 to it. then divide it. Is that clear? So it means you are going to have ax raised to the power of n plus 1 all over n plus 1 plus a constant. Are you following?
Yes, sir.
Do you understand?
Yes, sir.
Plus a constant. Do you understand? So this is the definition of what? Integration. As long as you know this formula of hand, you are done with integration. So now let us fix idea with one example. Example. Evaluate x or 2x raised to the power of 2 dx. Amen? Amen. So if now we want to integrate this function, what is your a here? 2, right?
Yes, sir.
What is your n there?
It's
It's 2, right?
Yes, sir.
So it means we are going to write 2x raised to the power of 2 plus 1 all over what? 2 plus 1 plus any constant. It could be b or what must be capital letter. Exactly. So now it means the final answer will now be 2x raised to the power of 3 all over 3 plus b. Amen?
Amen.
You can write it down. Come.
That's right. I was thinking, I really thinking that we can
Amen?
Amen.
Okay. So any questions so far?
So we can proceed.
Huh?
We can proceed, sir.
We can proceed, right?
Yes, sir.
It's okay. So now, assuming you are asked to evaluate integral x dx.
Yes, sir.
X dx. What should be the answer? You don't need to solve. What should be the answer? X raised to power 1 plus 1 because already one invisible one exists there. True or false? Then all over 1 plus 1 plus any constant, either g or yeah. Is that clear? So it means this is equals to what? X raised to the power of 2 all over 2 plus g. Amen?
Amen.
You can now see that these are indefinite integrals. Is that clear?
It is.
The reason why it is called an indefinite integral is, you know, it does not have what? Limits. No limits. But the definite integrals,
Yes, sir.
you see that we have limits. We call this one lower limits. We call this one what? Upper limits. So that's why these indefinite integrals, you integrate to obtain a constant. Look at the constant. You integrate to obtain. Can you see now? Why the definite integrals? You integrate to obtain what? Values. Is that clear? We will look at it. So with the help of this, I think we can be able to solve our definite integrals. So let's look at some examples before we go into the importance of Laplace transform. Otherwise, we always have issues or problems. Amen.
Amen.
I thought it's under the product of
Trying to
Get us back to
recap,
integration.
yes, and the
One
one
or
calculus.
so, but we can use the formula to solve.
Anything we want to do here is this formula that we are going to use. Is that clear? But I want us to have the
Background knowledge.
the background. You know, some of you, there are two of us. That is why
Yes, sir, like this movement.
that is why I'm trying to bring back your ND. Is that clear? To refreshing your memory so that by the time we continue, you will not find it difficult. Amen?
Amen.
Okay. So now, that is that for indefinite integrals. Let's consider definite integrals. You know, if we are to evaluate this, it means you don't need a prophet to tell you. This is the same approach. This will be what? X raised to the power of what? 1 plus 1 all over 1 plus 1. You now, because of this, you now convert it to what? At A to what? B. So it means there will be no more what? The integral sign.
Yes.
Don't write it this way.
Okay, sir.
This is straight line.
Yes. Is that clear?
Yes, sir.
After integrating the function.
Yes, sir.
Are you following?
Yes, sir.
Okay. So now, so it means this idiot, this idiot is equals to x raised to the power of 2 all over 2 at A to what? B. It implies that, this implies that we are going to subtract the lower limit from the upper limit. That is where the problem is. Amen?
Amen.
Okay. I think I can clean all of this, right? Okay. So,
Magic duster.
if you agree
I
with
use my
me,
magic duster. Yes.
not miracle duster. Sadiq,
Yes, sir.
not a miracle duster.
No, it's magic duster.
It's okay.
Get it from my village.
Okay. It's okay. Whether it's from your village or anywhere. It's okay. Let's proceed. Amen.
Amen.
Yeah. So now we want to find the values. So it means we will subtract this lower limit from what? The upper limit. How? It means anywhere you see x, you first write the upper limit minus the lower limit. So what we have here? X. So anywhere you see x is what? B. But x is squared, two of us.
Yes.
So it's going to be b raised to power 2 all over 2 minus the same thing. A squared all over what? This is all. So you can now see that, can you see the difference? This is the answer. Can you see the difference?
Yes.
The difference is that you integrate the definite integral to obtain value. While the indefinite integral, you integrate to obtain what? A constant. True of us. True of us. So take note of all this.
The upper limit comes before the lower limit.
Yes, the upper. That is why I said you subtract the lower limit from where? The upper limit.
So, sir, this is the important, right? The important.
No, we are still on ND, your ND level. Is that clear?
Yes, sir.
So now let us fix idea with one example again. Assuming you are asked to evaluate integral 0 to 2 x square dx. Amen? So now this is the same thing as what? Let's x x raised to not x2, x raised to power 2 plus 1 all over what? 2 plus 1. Then at 0 to what? 0 to 2. True of us. Then this will now x raised to power 3 all over 3 at 0 to what? 2. Amen?
Yes.
Then this will now be
2 power 3.
2 raised to power what? 3 all over 3 minus 0 raised to power what? 3 all over 3. You don't need a prophet to tell you. Already, here is 0, true or false? So we just face this side.
Yes, sir.
True or false? It means 2 raised to power 3 means what? 2 times 2 times 2. Which is what? 8 all over what? Can you see that? Definite integral, you integrate to obtain what? Values.
Sure.
Amen?
Amen.
Any question? Before we consider the importance of Laplace transform. So we'll be using this. As long as Laplace transform is concerned, you must have this in mind. Anything we want to do now, you must have it in mind. Okay.
So you are not going to consider it
Huh?
yes.
The S. And the S has vanished now because you have already integrated the function. You understand? Supposing you do not integrate the function, it will remain like this. I know some of you, you are expecting it to be like this. No. This means that you have integrated this function. So the S will disappear. Is that clear?